The essential question today is how can we analyze linear problems? And we're really going to concentrate on tables. Go ahead and pause it and read the word problem. Again, these boxed words we'll talk about later. But let's say we wanted 3 CDs. Now we're going to figure out the cost. It's $12 per CD. So I'm going to take $12 times the number of CDs, and then I'll talk about the coupon. Wait a second. We take 12 times 3, but then if we have a $4 coupon, that means you're going to get $4 off. So take away 4 and we'll see where we're at. And then you pick another number. We're going to write an equation. So another word for this word model, we're going to write equation. One of the ways we can write an equation is, notice what stayed the same every single time, especially within the middle group. Notice what stayed the same every single time, and notice what changed. Anytime you say 12 times, this is called a rate. And we're going to use a variable, because notice what changed every time needs to be a variable. So I'm going to use an X just to stay organized. So 12 times something, meaning X, and then subtracting 4 stayed the entire time, and that equaled another varying amount. We're going to call it Y. We're technically not used to this. We like to say rather Y equals something times X. We're used to that. But to start out, let's use the table to just get this going. So go ahead and press pause, read the problem, underline. So let's say I started off with 4 sales in this week. I'm not going to deal with 20% each sale. It's now becoming 0.2. So we're going to take 0.2 times the amount of sales, and then we're going to add in the 210 that we're supposed to get no matter what every week. So going to have to scratch this. I'm missing information because we need to know how much every single sale should be. So let's start over. Press pause and read this word problem. Underline important information, and I promise you this one for sure we will see a pattern within the table and it'll make sense. All right. We see this per word and it actually does make sense in what we're dealing with. So the number of days are going to vary. We're going to pick a day. We start off with 265 pounds on this trip. And then we're going to take away, because we're going to eat it, 15 pounds per day. So let's talk about how many days on this excursion. If we go one day, we start off with 265 and we're going to take away 15 pounds just on that one day. Left with 250. Pick another day. If we spend 2 days, we started off with 265, and if we take away 15 pounds every day, where are we at? See if you can figure out this amount. I'm going to show up the work and then put up the answers. Let's see what we get. So looking at the middle column, we're going to figure out, okay, what stays and then what changes, and whatever changes gets a variable to it. So I'll repeat that. 265 stayed the same, minus 15 stayed, but it was multiplying 15 times what? That varied every single time. Another varying factor was what we came out with. So the remaining food was a variable. Number of days was a variable, and the remaining food was a variable. We're not so much used to writing equations like that, so I'm going to write it off to the side. We're used to writing equations like this, with the y on the other side. Both ways are acceptable right now.
You wrote y twice.
Oh, thank you. So you've got a practice problem. I want to see if you can try it and develop your own model in the end.